Welcome to this explainer. Today, we're shifting our focus from just generating isolated AI code snippets to actually architecting real, secure software systems. If you've been messing around with generative AI, you already know it's a total game changer. But right now, we're zooming out to look at the big picture. Okay, let's dive into this. AI gives you the tools to build incredibly fast, right? But here's the catch. Without a human architect's vision, you're essentially just connecting dangerous, unvetted snippets. Writing a function is easy. Building an entire ecosystem where data is protected and rules are enforced, well, that requires a real architect. Here's our roadmap for today. We'll start with the full-stack mindset, then look at the front end as the human interface, dive into the back end and databases, understand vertical data flows, tackle security and validation, and finally, move from code to a complete system. Let's get into it. Section 1, the full stack mindset. So full stack development really means understanding the entire board, front end, back end, interfaces, you name it, along with data storage. Sure, AI can help with all of these layers, but developers are still pretty cautious. Why? Because just generating code doesn't mean the AI actually understands your overarching business logic. It's really about drawing clear lines of responsibility between all these interconnected pieces. Think of it like this. AI is basically your super enthusiastic intern. It's crazy fast, it suggests brilliant architectural patterns, and it explains complex concepts like a pro. But you're the human architect. You have to ultimately decide where a business rule actually belongs. You define the boundaries, you dictate the data flows, and at the end of the day, you take responsibility when things go to production. Moving on to Section 2, front end, the human interface. Now, the front end is highly visual and interactive. An AI can whip up a beautiful button, a complex React component, or an entire layout in literally seconds. But we have to ask ourselves, does it know what to show your user if the server suddenly goes offline? Does it understand your specific accessibility requirements? Or how to handle a user rage-clicking a button when the loading state lags? These are the crucial nuances that separate a shiny prototype from a truly professional application. The reality is, a gorgeous interface can easily hide a completely broken system. The front end is really just a translation layer. It's there to guide the user, give them immediate feedback, and stop simple mistakes. But it absolutely cannot be the sole enforcer of your application's security. It's a trustworthy guide for the user, sure, but from the system's perspective, you must treat it as an untrustworthy source of data. Next up is Section 3, Backend and Databases. So if the front end is the guide, the back end is your strict rule enforcer. Let's say you ask an AI to create a delete route for a file. It might generate that HTTP endpoint perfectly. It'll parse the request, and it'll delete the data. But it'll often completely forget step 2, checking if the user actually has the authorization to delete that specific file. Your backend must ruthlessly enforce your business rules before anything touches the permanent record. Then, at the very bottom of the stack, we hit the bedrock, the database. This is your system's permanent memory. It's not just some dumping ground for JSON files, folks. It uses rigid constraints, relationships, and transactions to protect data consistency. This means even if your application code completely fails or an AI-generated bug somehow slips through, your database can act as the final, unbreakable wall protecting your structural integrity. Which brings us to Section 4. Understanding vertical data flows. Now, the secret to really mastering full-stack architecture isn't about building out the entire front end all at once and then moving to the back end. No, instead, you build a narrow vertical slice of the application. Think of it like taking a core sample of the Earth. You want to touch the UI, the API, the business logic, and the database, all for one tiny feature, like updating a user status. Doing this immediately exposes integration problems. By testing this exact end-to-end data flow, you learn so much more than if you just built isolated parts. You'll quickly discover if, say, a database constraint rejects your front end's date format, or if your API is dropping authentication tokens. You catch these fundamental architectural disconnects early, way before you waste your time building 50 other broken forms. Let's dive into Section 5, Security and Validation. Here's a non-negotiable rule of full-stack engineering. Validation absolutely must happen redundantly. Your front end checks if an email looks like an email just to help out the user. But an attacker can easily bypass your browser form and shoot malicious data directly to your API. Therefore, your backend has to validate that email again and check authorization. And finally, your database ensures that the email is unique. 3 layers, 3 different purposes, completely redundant security. If you lean entirely on AI without this security mindset, you're honestly in for a rough time. AI can accidentally introduce some severe vulnerabilities right into your stack. It might write a perfectly valid API route, but totally commit broken object level authorization, meaning it forgets to verify if user A is legally allowed to view data B. Or it might casually suggest hard coding a secret API key right into your repository. You have to actively ask the AI, hey, what are the security implications of this code? Finally, we reach section 6, from code to system. So, what's the difference between an amateur and an architect? It's really all about how they treat the boundaries between systems. An amateur grabs unvetted AI code, pastes it into isolated files, and just kind of hopes it works on the server. A true architect uses clear API contracts, like open API specifications, and automated testing. By documenting exactly what the API expects, you ensure the AI operates within strict, documentable boundaries, rather than just guessing your application's architecture. When you're deploying to production with actual user data, AI is a fantastic assistant for things like generating deployment scripts or explaining weird build errors, but a human must definitively approve the database migrations. A human has to manage the secret environment variables. A local test environment is safe, but production is where real damage and real panic can occur, and that requires human accountability. Ultimately, what this entire explainer comes down to is ownership. AI gives you the absolute best spray cans in the world to paint this intricate mural of your tech stack. But remember, you're the artist holding the stencil. Take responsibility for the whole system. Because when the server inevitably goes down at 3 a.m., will you actually know how to fix it? Or will you just be sitting there waiting for the AI to wake up?